Hi students, and welcome to Deductive Geometry Part 2. Our WALT for this lesson is that you can understand the tests for congruency in triangles. What I'm looking for is that you can apply the tests to determine which triangles are congruent, and this is because geometry is important in many fields, including engineering and construction. Congruent triangles. Congruent is a word that is similar to the word used in congregation, where we're talking about meeting or gathering together. Congruent means falling together, and it means that if you get two shapes the same, for example, two triangles, and you pop them on top of each other, or they fell together on top of each other, they would take up the same outline. All right, so when we're talking about congruent triangles, we're talking about identical triangles. They have the same size and the same shape. The symbol for congruency is this funny equal sign with a wavy line on the top. And in this statement here, we've got triangle ABC is congruent to triangle PQR. Okay, so in our triangles, we've got three sides the same. This side is equal to this one. This side is equal to this side, and this side is equal to this side. So we've got three sides the same length, and then we've got three angles that are the same. This angle is the same as this angle, right? This angle is the same as this angle, and this angle here is the same as this angle, right? So if we were to flip around the second triangle and popped it on top of the first triangle, they would fall on top of each other, and you would just see the shape or outline of one triangle. Okay. So now we will look at a series of tests to prove whether triangles are congruent. And by the way, this congruency doesn't always apply to triangles. We could use it to prove that other shapes are congruent as well. But let's just focus on triangles for the purpose of what we're doing today. So the first rule is the triple S rule. Okay, S standing for side. So basically, if all three sides in one triangle are equal to the corresponding sides in the other triangle, then both triangles are congruent. And we could write that these two triangles are congruent because this side is the same as this side. Okay, and we've identified that with our notch. This side is the same as this side, it's the same length, we could measure that. And this side is the same as this side. Okay, so all three sides are equal in length to the corresponding sides in the other triangle, meaning that both triangles are congruent. The next rule is the Sas Congruence Test. This one's my favorite. This one says that two corresponding sides and the included angle are the same in both triangles. So if we have a look at this triangle, this side is the same as this side. It's the same length. This angle is the same as this angle, and this side is the same in length as this side. All right, so we could say both the triangles are congruent with our little congruency sign because of the Sas rule. Now, there is something we need to know about the Sas rule, and that is just a little reminder. Here we have an Sas man to remind us that the angle in our Sas rule has to be between the two sides that we're looking at. Okay, so we've got one side, then an angle, an included angle, and then the other side for our rule to work. Our AA congruency test. Let me just get my pen. Okay, AA meaning two angles and a side are the same. All right, so this triangle here, we've got this angle is the same as this angle. This angle is the same as this angle, and this side, which is in the middle of both angles, is the same. All right, in this triangle, this angle is the same as this angle. This angle is the same as this angle, and the corresponding side, so this side which is opposite to the angle, is the same as this side which is opposite to the angle. Okay, so with this rule, if we know two angles, right, we can work out this third angle here, okay, by taking it away from 180. So if we've worked out two angles, we already know that this third angle here and here are the same. Okay, so with this rule, we just need to know that two angles are the same in two triangles and another side. All right, it doesn't matter which side. Okay, in this first triangle, it's between the two angles that we're comparing. On this side, triangle here, it's the actual opposite to this first angle. Okay, it doesn't matter because our rule that we know that if we find two angles, we can already know the third. And so therefore we can say that all three angles are the same. This means it doesn't matter which side we're comparing, as long as it corresponds, okay? In that, what I said before, so this angle is opposite this side, and so there, and that's the side that we're comparing in this triangle. In the first one, it's the side that's between the two angles that we're comparing. Okay. And finally, we've got our Rhs congruency test. All right, Rhs meaning that it's a right angle triangle. All right, so we've got two right angle triangles, and the hypotenuse is the same length, and also a shorter side is the same in both triangles. All right, so Rhs, the hypotenuse and one pair of corresponding sides in two right angle triangles are the same. So we could say that these two triangles are congruent. All right, so in summary, congruency tests, we need to show three equal measurements in a pair of triangles. All right, so let's quickly pause the video and see if you can list the four congruency rules. Okay, so our four congruency rules are our SSS rule, our three sides are the same, or our Sas rule, all right, a side and then an included angle and a side are the same. Now Sas, we need to take care with this one, all right? There is danger in this one, in that the angle has to be the included angle between two sides that are the same, all right? Our Aas rule, two angles and a side are the same. And then finally our Rhs rule, which is just for right angle triangles, and the hypotenuse and a side, the corresponding side are the same. All right, so let's put this into practice. Select a pair of congruent triangles from the diagrams below. So pause the video and see if you can work out which two triangles are the same. Now the first thing I would do would be to try and calculate the missing angles in our triangles, right? Now I know that A plus 50 plus 95 will add up to 180 because of our interior angles of a triangle rule. Okay, so we'd work out then, if we went 180, take away 95, take away 50 in our calculator, we'd work out that A equals 35 degrees, all right, 35. We could also work out the angle missing in this second triangle, right? So B plus 95 plus 35 will add up to 180 degrees. So B will equal to 50 degrees, all right? 50 degrees. And this triangle here, all right, angle C plus 35 plus 95, we can see from our other triangles that C is going to equal 40 degrees also. No, 50 degrees, sorry, 50 degrees also. All right, 50 degrees. All right, my next thing that I would do would be I would compare the sides. All right, now we need to make sure the sides are corresponding. So what that means is in our first triangle, okay, we'll call this triangle ABC, right? The side that's 15 centimeters long is opposite the angle that's 95. All right, if we look in triangle B, right, our side that's 15 is opposite our angle that's 95. So these two triangles, right, are congruent. But let's just compare, for example, over here, our angle that's 95 is opposite to a side that is 18 centimeters long. That is not 15, right? So this triangle is not congruent. Goodness me. So select a pair of congruent triangles from the three below and give a reason for your answer. So the first thing we need to do is calculate our missing angles. Okay, so angle A, we know from our interior angles of a triangle rule that A plus 65 plus 70 will add up to 180. All right, so if we went 180, take away 70, take away 65, that'll give us A equals 40 degrees. 45, sorry, 45 degrees. All right, this triangle here, right? B plus 65 plus 70 equals 180. All right, so if we went 180, take away 70, take away 65, equals, we'll get B equals 45. All right, and finally, let's work out this one as well, just to be thorough. Triangle 3, C plus 65 plus 45 equals 180. All right, 180, take away 45, take away 65 will give us C. C equals 70 degrees. Okay. All right, so we've got 3 triangles with matching angles. Right, so that's great. We need to see if the sides are congruent as well. All right, so for example, let's just take, it really doesn't matter which one, let's just take, I'm going to get a different pen color just to help us out a little bit. Let's just take this side that is 65 degrees and compare it. Okay, so our side here, which is 3, is opposite our angle, which is 65 degrees. In this triangle here, we look opposite the angle at 65 degrees, the side is 4, right? So the first two, 1 and 2, these two are not congruent, okay? Not congruent. Now, let's have a look at this triangle. The angle that's 65 degrees is opposite the angle, the side that's 3. All right, so therefore, and we'll also compare, let's compare with, all right, so so we've already worked out that triangle 1 and 3 are congruent, goodness me, but let's also compare, so if we look on this one, the angle that's 70 degrees is opposite the side that's 4, right? So side that's 70 degrees is opposite the side that's 4, right? So that is the same in both of our triangles, right? So triangle 1 is congruent to triangle 3. Probably shouldn't really write it like that. Let's just write it as triangle 3. Because of we used our angle side rule, okay, our Aas rule. Okay, again, we'll just calculate the interior angles that's missing. All right, it's going to be 30 degrees. I'm just going to get my pen in a sec. Okay, 30. Actually, in all these triangles, it's going to be 30. Okay, so now let's look at corresponding sides. We've got one side that's the same in each of the triangles. Okay, so let's have a look. In this triangle, all right, the side that's 6 centimeters is opposite the angle that's 40 degrees. All right, so let's have a look at this one. Here's our angle that's 40 degrees, so we're comparing the same angle. We look at the side opposite that, all right, which is 6. So these two triangles are congruent. All right, let's have a look at this one here. So we'll identify the side that's 40 degrees. Let's draw a line, an arrow to look at the opposite side. Right, that is not the side that's 6 centimeters. Okay, our 6 centimeter side is down here. It's next to or adjacent to the side that's 40 degrees. So therefore, this triangle is not congruent. All right, the first one, 1 and 2, are our congruent triangles. All right, Theorem 4 says that the angles at the base of an isosceles triangle are equal. All right. Okay, so if we look at our triangle, what we're saying is that angle A equals angle B. All right, now we can prove that in our isosceles triangle. If we draw this line directly in the middle of our triangle, so line CD, okay, we divide our isosceles triangle into 2 equal parts. All right, so we could say that the side CD is the same in both triangles. Okay, so this first triangle, maybe I'll get my laser pointer, that might work a bit better. Let's do that. Okay, so triangle ACD, all right, and triangle CDB, all right, they both have the same side here, okay, CD, which is the same in both triangles. So let's just write that down. All right, so CD side equals CD. It's the same in both triangles. Now, we can also see that these two sides are equal. All right, so we've got another side that's the same, and also because it's divided in half, these two sides are the same. All right, so we have three sides the same length, so we could say that the triangles are congruent because of our Sas rule. Okay, as a result of the two triangles being congruent, all right, angle B must equal angle A because of our Sas congruency rule. All right, so given that our two triangles are congruent, all right, let's just get my laser again to make that clear. All right, so we're saying that angle A, B, and D, this first triangle, is congruent, okay, because of this little symbol up here, congruent to triangle C, B, D. All right, both these triangles are congruent. Find the values of the pronumerals. All right, so find what X, Y, and Z equal. All right, so pause the video if you'd like to have a go. Otherwise, let's do this together. All right, so they've told us that triangles are congruent. So we know that, okay, if we use the Sas rule, okay, we know that the three sides in the triangles are going to be equal. So the corresponding sides, right? So we know that this side equals this side. We know that this side is the same in both triangles because it's the shared side. And we know that this side has to equal this side, all right? So we can say that X equals 3 centimeters because of our Sas rule. All right, let's have a look at our angles. All right, so we know that these two angles are the same, okay? And we know that this angle, 40, is going to be the same as Y. All right, so Y equals 40 degrees. All right, and finally, Z has to be the same. Z has to be the same as this angle here, which is our right angle triangle. Therefore, Z equals 90 degrees. Find the value of the pronumerals. All right, so find X, Y, and find X and Y in both these questions below. Pause the video and have a go. Okay, so I'd have a look at this triangle and notice that it is an equilateral triangle. All three sides are the same. All right, and also another side, this side on this triangle, this side CD, is the same as the sides in our equilateral triangle. Okay, so 6, this side is 6, meaning that this side must be 6 as well, meaning that X must be 6. Okay, the other thing that we can see is because it's an equilateral triangle, all three interior angles are going to equal the same. So they're all equal to Y. So if we went Y plus Y plus Y, or 3Y, is going to add up to 180. All right, so if we went 180 divided by 3, we'll find out that Y equals 60 degrees. All right, in this question here, we've got two parallel lines. All right, so we can start thinking automatically of the rules like our alternate angle rule. Okay, this one, where the two angles are the same. Or we could think of we've also got some of these opposite angles, could be the same. We also could use our supplementary angle rule, okay, where they both add up to 180. So let's have a look and see if we can identify any of these in our question. All right, so straight away, I think we've got a supplementary angle here. So let's work out what this angle here is. We'll call this angle B. All right, so 130 plus B will add up to 180. All right, which means that if we go 180, take away 130, our angle B will be 50 degrees. All right, so let's write that on our diagram. This is going to be 50 degrees. All right, so if we look at this triangle here, it is an isometric triangle, isosceles triangle, sorry, get the right word. Isosceles, meaning two sides are the same, all right? Which means that these two angles, right, angle B and this angle here, we can call it angle B as well, both these angles will be the same. All right, so if it's 50 degrees here, it has to be 50 degrees over here. So we could then work out x, all right, because we could go that x plus 50 will add up to 180. All right, so x plus 100 equals 180. So x is going to equal 80 degrees. All right, so the final thing that we can work out is we can use our nice alternate angle rule just here. All right, so let me get a different color to make this a bit easier to see. I might use my purple pen. All right, so this angle here is going to be the same as, if we look at our Z, this angle here. All right, so if that's 50 there, this angle has to be 50, and then Y is going to be 52 because it's opposite to that. All right, so we can say that Y is 50. All right, degrees. Okay, because of our, and you would have to go through, sorry, that's actually really messy, but you would have to go through and show why it's equal, because you would say because of our alternate angle rule and our opposite angle rule. Okay, so in your test, make sure you go through and show all your working. Okay. Find the value of the pronumerals. Show your reasons. All right, so let's do question C first. All right, hang on, let me just get my pen. That'd be smart. Okay, here we go. So question C. Right, first thing I notice is that we've got two parallel lines. Okay, so we start to think about our alternate angles rules. All right, we want to calculate, and the other thing I notice is that we've got an exterior angle here, and we've got two opposite angles. All right, now we know from our opposite angle rule, so our exterior angle will be the same as the two interior angles added up. All right, so what we're saying is that 99 equals to y plus 32. Okay, so y is going to equal 99 take away 30. Right, so 99 take away 32 will give us 67. All right, so we've worked out that's 67 here. Now, I also know from our alternate angle rule, let's use that one because it's awesome, that, let me get a different color too, 99 will be the same as this angle here, okay, because here's our Z, okay, and here's our first angle, here's our alternate angle. Right, so what we're saying there is that x plus y, which we know is 67, equals 99. Okay, so x plus 67 equals 99. So 99 take away 67 equals 32. All right. All right, so x equals 32, y equals 67, all done. All right, let's have a look at question B. Okay, find out the angle of y and x. All right, now I can see two sides that are the same, first of all, and I can see that both triangles share this side here that I'm just circling, this side. So this is the same in both triangles. All right, we could put it with like two notches, so we know that that's the same. Now, the final thing is that this triangle has a right angle here, okay? And we know from the supplementary rule, right, that the two angles have to add up to 180. All right, so if the first angle is 90 degrees plus, let's call this B, which we're trying to find out, B equals 180, we know that B has to equal 180 take 90, which is 90, right? So what I'm trying to say is that this angle here is a right angle as well. All right, so we've got two sides the same, and then the angle that is in the middle or the included angle is the same in both triangles. Aha, so that is our side angle side rule. That tells us that the two triangles are congruent. So you'd write that down, all right? Triangle 1 and triangle 2 are congruent, right? You could even write triangle AB, right? ABE and triangle ABE are congruent, right? As long as you show you're working what you're doing. And so because of that, because the triangles are congruent, therefore 45 and y must be the same. So therefore y equals 45. And we could work out that x, all right, then from using our interior angle rule, so the three angles add up to 180, x plus 90 plus 45 add up to 180. All right, so x is going to equal 180. Take away 45, take away 90 equals 45. All right, should have known that actually, but anyway, 45 degrees. All right, so that is the answers all done. Find the value of the pronumeral in each of the following pairs of triangles. Okay, let me just get my pen first, that would help. Okay, so in A, all right, let's compare the angles that are the same, right? So this angle is the same as this angle. And this side is adjacent to the angle that we've just identified, right? So this side is adjacent beside our angle with the two notches, right? So we can say that x equals 3, okay? Because we've said that the triangles are congruent and 3 and x are corresponding sides. Okay, question B. Right. If we have a look at this angle here, 85, and we identify which side it's opposite. It's opposite the side with the 3 notches. So we go to our second triangle. Here's the side with the 3 notches on it. Let's have a look for the angle that's opposite, which is angle x. Okay, therefore, x has to be 85 degrees because we've worked out that x corresponds to, it's the same angle as 85 degrees. All right, question C. All right, let's have a look. So we've got angle that's 30 degrees. It's opposite side that's got 1 notch. Look at the second triangle. The side with 1 notch is that one here. All right, the angle that's opposite is angle y. Therefore, angle y must be 30 degrees. All right, let's have a look. So the 80 degrees is opposite the side with 3 notches. All right, and our second triangle, 3 notches is this one here, all right, which is x. Therefore, x equals 80 degrees. And to find out our last angle, right, we know that from our interior angle rule, this rule here, our 3 interior angles will add up to 180 degrees. So z plus 30 plus 80 equals 180. All right, so that means that z equals 70 degrees because I went 180, take away 80, take away 30 equals 70 degrees. What rule can you use to prove the following triangles are congruent? Right, so pause the video and have a go at this. All right, well, I can see, first of all, that side PS, right, is the same in both triangles. So let's put 2 notches there. This side and this side are the same, and this angle and this angle are the same, right? So we've got 2 sides that are the same and an included angle, which is the Sas rule, proving that the 2 triangles are congruent. All right. Question B. All right, we've got 2 parallel lines, right? So straight away, I start to look for alternate angles, right? So we know that this angle and this angle are the same. All right, and let me change my pen just to give it a different color, right? And this angle and this angle are the same. Let's call this A, and let's call the other one B and B just so we can see it a bit better, right? So angle B and angle B are the same. And because we know that 2 angles are the same we know the third angles must be the same. We've also got a shared side. So this side here, this QS side, right, is shared by both the triangles. It's the same. So therefore, we've got a side that's the same and two angles. The Aas rule tells us that the triangles SPR and SRQ are congruent. Okay, let's have a look at triangle at number C. All right, so we've got two angles are the same. Another two angles are the same. And this shared side is the same. Sorry about that wobbly line there. All right, so two sides are so that side's the same. Two angles are the same, right? So we can use the angle side rule to tell us that the two triangles are congruent. All right, now this one, we've got some opposite angles, okay? So if we've got opposite angles, we know that they are the same, right? So we could say that this is angle A, it's the same. We've got two sides. They've given us that this side is equal to this side, all right? And they've told us that this angle, right, is equal to this angle. All right, so we've basically got two angles, right, and a side that are the same. So therefore, the two triangles are congruent because of the Aas rule. How did you go in your learning today? Can you remember the congruency rules for triangles? All right, so we've got the side, side, side rule. So our three corresponding sides in a triangle are all the same length. We've got our side, angle side rule, which means two sides are the same in both triangles, plus the included angle is the same in both triangles. And that's the one that we need to make sure it is the included angle, okay? Then we've got the angle side rule. So two angles and a side are the same in both triangles. And last one, we've got the Rhs rule, which is for right angle triangles. Okay, and it's the hypotenuse is the same in both triangles and a short side are the same in two corresponding triangles. All right, so if you know all that, guys, you're on fire, you're doing well. Keep practicing. Have a great week and we'll see you soon.